Hey there, guys and gals. This is lesson 23, and we're working on problem solving using rates, unit rates, and conversions. Last lesson, we worked on constant speed problems, and now we're going to work on constant rate work problems. And I think I read someplace in here, if you need a calculator to help you with some of your work, that's okay. I'm just going in here and choosing my pen. So it starts out, if work is being done at a constant rate by one person and at a different constant rate by another person, both rates can be converted to their unit rates and then compared directly. So work can include jobs done in a certain time period, rates of running or swimming. First one we have here is we're working on cutting grass. And we have 3 lawns is taken care of in 5 hours. And then your friend over here, I'm looking at 5 lawns can be done in 8 hours. And we want to know who is cutting lawns at a faster rate. So we want to, with my 3 and my 5, I want to divide. So I've got 3/5. If I have 3, and I'm dividing that by 5, this is going to be a 6. So this is, I'll put my 0 here as well. 6/10 of a lawn would be done in an hour. So a little bit more than half. So over here, if I do my math, I have my 5, my numerator, my denominator, my 8 is out here. I put in my decimal. Put my decimal up top too so I don't forget. So 8 times 7, no, 8 times 6 is 48. So I get 2 and then 0 brought down, so that would be 2, and that one was just a 0. Okay, 16. Okay, there's my 4, take another 0, that's my 5. So this one is 0 and 625,000, oh my gosh, lawns. So if this is a 0, my friend is able to cut at a little bit faster rate. Not by much, but by some. So I've got 3/5 and 3/5 and 5/8. I'm comparing those two. And so I think, isn't that all I have to do on that? Who is cutting lawns at a faster rate? It would be my friend. My friend cuts lawns at a faster rate. I know. Okay, let's go to the next page and see what we have. This one says, suppose now you've got a restaurant. You want to do some advertising, so you hire 2 students to deliver takeout menus all around town. One student, Darla, she delivers 350 menus in 2 hours. And another student, Drew, he is delivering 510 in 3 hours. Well, you promise a $10 bonus to the fastest worker, since time is money in the restaurant business. That's true. Who gets the bonus? So we just heard, or no, I was saying it, so you did probably hear, but if I go 350 menus, I'm going back to Darla's info, and that was in 2 hours. So now I want to do division. So divide that. So there's 1, 2, 1, 5, 7, 1, 5. So 175. So, and this is our rate. 175 menus in an hour is what Darla is able to do. So I'm just going to put that info there. And then I'm going to go over here and take Drew. This is Drew's data. It said he was able to deliver 510 in 3 hours. Well, let's see, 510 divided by 3 is, there's 1, 3, there's a 7, and then a 0. So that is 170 menus in an hour. So not quite 175. So he's a little bit slower. So if this is the information that we have, we would say that Darla gets the bonus, right? Darla gets the $10 bonus. Got it. Boom. Okay. Don't we have menus an hour, menus an hour? So that all works. So go to the next problem and see what we have. This one is survival of the fittest on, page 250. I think I have this a little bit chopped off. So which runs faster, a cheetah that can run 60 feet in 4 seconds or a gazelle that can run 100 feet in 8 seconds? So I'm going to put in, I know this one has it so that you can write it, but 60 feet in 4 seconds. And this is the gazelle that was 100 feet in 8 seconds. Okay. So let's go. I'm going to take my numerator, divide by my denominator. This is a 1, 20, that would be 5. So 15 feet in 1 second. That is fast. And then I'm going to take my 100 and divide that by 8. Then I get 20, and so then there's my 2, 16, 40 is 5. So, but I need a decimal there, don't I? Because that was 100. So that's 12.5. Almost made a good error there. So I have 12.5 feet a second, or 15 feet. So this is definitely the cheetah is the fastest. Got it. I should do a capital. Okay, so we've got that taken care of. Let's see if there's a problem here. Yep. What if the units of time are not the same in the two rates? What will this mean for the rate units? The secretary in the main office can type 225 words in 3 minutes. So I'm going to write that in, 225, and it said in 3 minutes, while the computer teacher can type 105 words in 90 seconds. Okay, so I want to either convert seconds or I want to convert to minutes. How about, I think I'm going to take the 90 seconds and go 1 minute and a half, right? 1.5 minutes. That's what I'm going to do on that one. We can't compare if we don't have the same unit of measurement. One of them has to be converted. So let me do my 225 divided by 3. So that'd be a 721. 15 is 5. So this is 75 words a minute. Okay. And then this one, I've got 105. 1.5, so I'm going to bump over. I'm going to add a 0 and put my decimal up here. So that would be a 0. So how many 15s? How many 15s are 1050? And how many 15s? If I go 7, that's 5, 3. Oh, that works out perfectly. Okay, 0, 0. 0. Okay, so that is 70 words in 1 minute. So that was a little bit more involved with the decimal, and I bump it over so that I don't have any decimal. I don't have any decimal in my number that I'm my divisor. Okay, can we still compare the units? We have to change. We have to change them so that they're the same. It says, here's a hint, convert the seconds to minutes, and we did that. Okay, so we're done with our classwork. Well done.